We have a fun example here. Chris, how can I make best use of my laptop's accelerometers in building things like augmented reality interfaces, also cameras?
Yeah. Well, this is a fun question. Sometimes Mathematica is so fun it's hard to get any work done. It's an occupational hazard of working at Wolfram Research. Let me start with the accelerometers. So there is a function called controller information that will tell you what kind of devices you have hooked to your computer. And I'm working on a Macintosh, so you see down here there's a sudden motion sensor. And if I open that up, there's a part labeled Mathematica controls. And I'm going to pick up my laptop now and move it around. You can see that the X and Z values are changing as I tilt my laptop. So that's the built-in accelerometer in the Macintosh. If you hook any kind of standard standard gaming device like joysticks or controllers, whatever, Mathematica will automatically recognize them, and you can use this controller information to find out what the devices are that you have access to. So if you want to use these, you look down here, you find out the name, sudden motion sensor, and you find out the names of the controls, X, Y, Z in this case. Now only X and Z actually update. So I'm going to use those now to control and manipulate. So let's make a digital level. I'm going to turn my laptop into like a bubble kind of level. And I'm going to do that by making a graphics. And the graphic will have I'm going to make something that kind of simulates a spirit level. So let's make an orange rectangle. And I'll make the rectangle go from, say, I don't know, minus 10 to 0. Let's make it minus 1. Minus 1, 0 to 1, 1. Okay, so there's a rectangle. That's a little bit thick. Let's make it 0.1. Okay, that's good. And now I'll put in the bubble. And the bubble will be let's say, a gray circle. And I'm going to position it at a horizontal coordinate x, y coordinate 0, and let's give it, let's make that 0.05, so it'll be in the middle of my orange rectangle, and give it 0.05 radius. And now let's let x go from minus 1 to 1. Okay. So now I have a device that I can control with the slider. Let's make that white. It's a little bit hard to see when it's gray. Okay, now I want to hook this up to my laptop's accelerometer. Well, I looked and found out that the name of the controller I want to use is sudden motion sensor, so I'll tell manipulate to use controller linking. Sorry, not controller linking. So if you forget what the names of options are, for example, in this case, control, I know it begins with controller. I'm going to type controller star with a question mark, and I can get all of the options which are which start with controller. So what I really want is controller path here. So controller path, sudden motion sensor. Okay. And I have to tell it which of the variables in the controller to hook up to my manipulate parameter. I want the x of the controller to correspond to my manipulates x. And now let's see if this works. So I'll evaluate this, select the output, and it doesn't work. Oh, here we go. It's working. So I'm tilting my laptop now. It's just barely moving, which means I have some scaling problem here. I know what I'm missing. So by default, the controller uses relative values. What I want are absolute values. So the way to do that is using controller method and say absolute. And now I'll select the output. There we go. That's what I wanted. Okay, so now I'm tilting my laptop back and forth, and just like a level, that bubble's moving, and if I hold it perfectly level, I get the bubble right in the middle of the thing. So I've just simulated a spirit level. Okay. Let's move on to cameras now. So if your laptop has a built-in camera or a camera connected to it, you can find out using imaging devices. Okay, and this will tell me what I've got. I've got a built-in eyesight camera, and I can get at that using current image. So if you say current image, evaluate that, the first time you do it, it takes a couple of seconds to fire up the computer's imaging system, and there it just took a snapshot of me. If I wrap this with dynamic, it will update dynamically, and now you get a video of me. Okay, so what can you do with this? You can give current image an argument. Say I want the last 2 frames of the dynamic, or of the current image, and it'll take a little bit to evaluate, and then it'll get going. There we go. So now I've got the last 2 frames. Let's now take the difference of these 2 images dynamically. So I'll say image difference. And using the @ notation means replace the list of 2 images with image difference of the 2 images. And now if I evaluate this, if the image is unchanging, the difference is going to be 0, or a black image. That's what you see there. If I move, now you can see me moving because the difference changes. So in this little one-liner, I've made a motion sensor out of my camera.
Oh, that's fantastic. We had a user follow up with a question. That's great. What about microphone input?
Microphone input. Help me out. I believe there is a way to do it. It's not something that I've done before.
We can record it, but I don't think at the moment, for instance, you cannot do something interactively. It's a limitation on actually sound card side, it's interruption and these things, So usually sound part is old technology. It doesn't work that well with the interactive technology at the moment.
Okay.
But, yeah.
No, great.